Today's topic is branches of chemistry. There are many branches of chemistry, but few are mentioned here. First is the physical chemistry. In physical chemistry, we study the physical properties of matter, structure, and laws and theories. It should be kept in mind that there is a golden triangle in science: hypothesis, theory, and law. Hypothesis is a raw idea. When it is substantiated by a mathematical proof or other indirect proof, it becomes theory, like you can say the theory of relativity. When it is proved practically, it becomes law. It's a law of gravitation. Earth attracts bodies towards itself. So this is a triangle. Then there is organic chemistry. There are 118 elements, and one of them is carbon, which is called king of elements. The compound of carbons are known as organic compound, and their study is called organic chemistry. When we use word study, it means study of physical properties as well as chemical properties. But there are few exceptions. That's carbon monoxide, carbon dioxide, carbonate, bicarbonate, cyanide, cyanate, carbides. Though they are made of carbon, but they are not organic compound. They are inorganic.
Why are these compounds are not organic?
Because these compounds are very simple compounds. The property of organic compound is their complexity, where the property of inorganic compound is simplicity in general. They are simple, so they are not included there because they do not show the nature of organic compounds. And while inorganic chemistry, all elements, we study all elements except carbon. Okay, but these carbon compounds are also included in inorganic chemistry. So we have got two types of compound: organic compound and inorganic.
How do they distinguish between organic compounds and inorganic compounds?
Distinguish between organic compound and inorganic compound is very simple one. You need just a matchstick. Burn it. Burn the organic compound. If it burns into ashes, it's organic compound. If it doesn't burn, it's inorganic. Then there is analytical chemistry. Analytical chemistry means when we study the quality and quantity of a substance. For example, I have got this copy. See, for the material from which it is made, it is a cord, this is a paper, there is a glue, there is a thread. So this is a qualitative analysis. And now I measure its quantitative analysis by weighting the cord and have a mass of the paper, glue, and thread. Measurement of its quantity is quantitative analysis. So in analytical chemistry, we undergo qualitative analysis and quantitative analysis. Biochemistry, the chemical reaction occurring in living organisms. When we study them, this is biochemistry. Then there is applied chemistry. It's also known as a industrial chemistry. Application of the knowledge of chemistry for the benefit of the mankind. So there's applied chemistry. We make medicines, we make a lot of things, toothpaste, shaving creams, etc., etc. Medicines, already have mentioned. These are valuable things for the mankind. So there is a difference. These subjects are known as pure chemistry, and this is a applied chemistry. Then there is an environmental chemistry, which is very important nowadays. When we focus our study on the pollutant are the harmful things, harmful substances. What are their sources, what are their reactions, how they are transported, and what is their effects on the environment and on mankind. This is known as environmental chemistry, especially generated by the human activity. For example, we take the example of CO2. CO2 is, what are the sources of CO2? 75% is produced by the burning of fuel in the automobiles. Okay. What is their reaction? It's combined with H2 to form carbonic acid. Carbonic acid with rain comes to the earth, and when it falls on earth, acidity of the earth increases. It fall in the water, acidity, it makes water acidic. fall on the marble building, it react with them and corrode away the marbles, etc. by making bicarbonates, and bicarbonates are soluble in water. So marble building or other building corrodes away. And how they are transported? Carbon molecule is like a butterfly, it is like a bird. This is a carbon, this point is a carbon, this is oxygen, and this is oxygen. It moves like this. It moves fly like a bird. That's why I've shown it like a bird. And when carbon dioxide accumulate in the upper atmosphere, sun rays, which includes almost 14 different wavelengths, and comes to Earth, and at the evening and night they are reflected back, and the IR radiations are captured by the CO2 layer. And when this molecule is rotating, vibrating like this, when it will absorb heat energy, it will start vibrating like this. So it will store energy and the temperature of the Earth will rise. It is expected by the scientists that in the coming 50 years, there is a likelihood of rise in temperature from 1 to 5 degrees centigrade, and it will increase the level of water to from 1 to 5 feet. And so the islands which are already lower, like Sri Lanka and Netherlands, they might sink. So it's not a good sign for the humanity. Here I have mentioned another thing in the definition, that is created by the human activity. In fact, nature sends 10 to the power of 12 tons of material per year in atmosphere, whereas human activities generate only 10 to raise power 8 tons per year. It becomes only 0.01% of the material present in the atmosphere due to human activity. But we cannot do with the natural process. So we focus our attention mainly on the human activity. So these were the few definitions, and thank you for paying attention.